Welcome back. I'm Professor Don Patterson, and we're in the middle of a long series of coding trying to get Othello, or Reversi, the generic name, working as a web application. In this video chunk, what we're going to do is we're going to add the ability for the server to calculate what the legal moves are that a player can play. We're going to communicate those to the client, but we're not going to enforce them in this video. We're going to save that for another video. All of this work is calculation on the server side. And so we're going to go there to start. So let's jump over to Visual Studio Code and take a look at what's going on there. We'll load up server.js. And what we're going to do is we're going to change a little bit the way in which the information that we send over to the client is going to have the current state of the board, but it's also going to have a state of where a player can play also. Before we get going, we need to make one housekeeping change, and that's way up at the top under Create New Game. We're at the top. Now we scroll down, set up our server, set up our connections, our server log, our join room. Actually, I was wrong. It's not way up at the top. It's maybe down at the bottom. Sorry, it's at the bottom. It's at the top of the code that's not in the handler. So what we're at is we're at the create new game function. This is the function that launches a new game and creates the initial data structure for our game. The first thing that we need to do is when we launch that, we need to initialize the new game.whoseTurn, so that's not white, instead it's black. That's because according to the Reversi game rules, black plays first. And we had that wrong when we first got our game. So let's fix that so we're following the rules correctly. Now the next thing that we want to do is we want to calculate those legal moves. And so what we're going to do is when we come down here, after we create our new game board, we're going to add something to our structure, new game. And what we're going to add is we're going to add another object, which is the legal moves. And we could just take a board like this, for example, and copy it and insert it there. But instead, we're going to work with a function that we're about to write, which is going to calculate the legal moves. And what we're going to pass that function that we haven't written yet are some parameters. We're going to pass it the player that we want to calculate the legal moves for. Since this is the first player, because we're creating the new game, that's going to be B for black. And we're going to pass it the board that we want to have calculated the legal moves for. So we're going to ask for all the legal moves from the new board we just made for the player B. All right, but now we have to write that. So writing this function is actually going to entail writing 3 different functions that we're going to use to help to calculate the whole kit and caboodle. So let's go up above, let's go down below since it makes a little bit more sense and it's right there. And let's create a new function called calculate legal moves. And we're going to receive a parameter. We don't know who it's going to be, but we'll call it who. And we'll call the board that we're going to work with board. And you can see that the B is mapping to the who and the new game.board is mapping to the board. But we'll call this function other places as well. So we want to keep it kind of generic. All right. The first thing that we need to check is we need to make sure that the position, we need to start out with a board that we can add things to. So I'm going to come up here and I'm going to grab the blank board here and I'm going to copy it down into our function. And I'm going to give it a new variable name and we'll call it legal moves. And we're going to fill this out with the places where it's legal for the who to move. And so we want to start out with it being all spaces. So we're going to change that because initially we say there's no legal place to move. Now to that, we're going to do a doubly nested loop because we're going to go through each one of those positions one by one. So we have this code other places. It's just as fast for me to rewrite it here. So while let row equal 0, while row is less than 8, row plus plus, that'll be the outer loop. And then we'll do another one where we change row to column. And that'll be the inner loop. Save that up and format it. In each one of these positions, what we're going to do is we're going to check to see if each position is a legal move. So for starters, it has to be a space. If it's not a space, you can't move there. So let's check that first. So we'll check to see if the board, sub-row, sub-column, triple equals a space. And if it is, then that's a first prerequisite. If it isn't, then we don't have to change anything because the way we'll represent this is that a space, it is legal if your token is in that space. So a space is not legal, but it must be a space in order to identify whether or not it is legal. You can't play in an empty space. That's all I'm trying to say. All right, so we'll have some helper functions here. And we're going to ask if the position immediately north of us, whether or not that's a legal place, whether or not that is a legal move. In order for a position to be a legal move, one of the spaces around it has to support it being a legal move. For example, when you play in Othello, your color has to play next to a position that is the opposite color. And in addition to playing next to a position that's an opposite color, it also has to have a partner piece at the other end of a row so that you can flip everything in between. So what we're going to do is we're going to have a helper method which says, let's see, we'll call it like adjacent support. We'll just call it adjacent support. And we're asking, is it adjacent support for what color, who, and what are you adjacent to? So we're going to say going north means that we're going to subtract 1 from the row and we're going to keep the same column. And we will enter in the anchor position here. So our anchor position is row column and the board is like this. And so adjacent support means that, all right, well, if we start at position row and column and board and we move up 1 and keep the same column, can we play there? And that basically what it means is does that spot have an opposite color? So we're going to look at the north position and we'll look at the south position. Instead of going up 1 row, we'll go down 1 row. We'll add 1. And we're going to also look at the west and the east. And west means we are subtracting 1 from our column. And east means we are adding 1 to our column. Diagonal play is allowed in Othello, so we will also look at northwest. And northwest means we're subtracting 1 from the row and the column. And northeast means we're adding 1, subtracting 1 from the row and adding 1 to the column. We know that southwest is also valid. That means adding 1 to our row and subtracting 1 from our column. That's southwest. And then southeast means that we're adding 1 to our row and adding 1 to our column. So that's 8 different positions that we have to check, all of the positions around a particular position on our board. If any of those positions supports our play, then we can play there. All right, so what we're going to do is we're going to put together a long if statement here. And we're going to say if northwest provides support, or north provides support, or northeast provides support, or west provides support, or east, or southwest, or south, or southeast. If any of those places offer support, then we're going to go ahead and put into our legal moves array at position row and column, we are going to insert the color that's allowed to play there. So we'll go through every position on the board and ask if there's support, and if there is, we'll put that in legal moves. And then the last thing down here is when we're done looking at all the positions, we want to return legal moves as the data structure. Save that, reformat everything, looks okay. Now we need to write adjacent support so that we know whether or not it is valid to play next to a position. So let's come right above the function valid moves and let's write our function for adjacent support. And that's going to receive, let's see, the different parameters are going to be, we'll call it who, that's the player that's playing. We'll say dr, and that stands for delta r, how much we're adding to r. And dc, which is delta c, or how much we're adding to the row or the column. R for row and C for column, the position we're starting at. And then the board we're evaluating. This will return true if R plus dr supports playing at R and R plus DC, and C plus DC supports playing at C. All right, so to check that, we're going to need to know what the opposite color is because we're looking for the opposite color. So we'll define a variable called other, and we'll say if who triple equals black, then other equals white. And we'll put an else statement in there. If we are looking at white, then the other is going to be black. And if we have something else, then we're just going to log a problem. And we'll say, Houston, we have a problem, and we will log what the character is that we weren't expecting. And we will return false because this position doesn't support that. Okay. We've calculated what the opposite of the color is that we're looking for. Now what we want to see is we want to make sure that we weren't asked whether adjacent support is coming from a position off the board. So check to make sure that the adjacent support is on the board. And the way we'll do that is we'll say if r plus dr is less than 0, we've walked off the board, or r plus dr is greater than 7, we've walked off the board in the opposite direction, then we'll return false because we can't provide support if it's not coming from the board. We'll do the same thing, copy that, and do the same thing with the columns, C plus DC or C plus DC. Okay, so R's and then C's. If either of those are true, then we've walked off the board and we can't provide support. And then we want to check to see whether or not the opposite color is next to us. If we're not next to an opposite color, then we can't provide support. So we want to check that. We want to say if the board at the position that we're currently asking about the position, if the board at the position we're asking for support from, R plus DR and C plus DC, if that is not double equals to other, then we can return false. So if you have to be adjacent to an opposite color in order to play there. We want to play at R and C. R and C is the proposed place we're playing, and R plus DR is the adjacent support we're looking at. So if R plus DR is not equal to other, then we'll return false. All right, now we need to check to make sure that there's space for another token of your color to be present so that we can capture pieces in between, because you have to be able to capture pieces in order to do that. So we're going to look one additional space beyond that. So I'm going to capture this code up here again. I'm going to copy it down here, and I'm going to check to make sure that there is space for a matching color to capture tokens. Yeah. All right, and what we're asking is R plus DR plus DR, so 2 spaces away, less than 0, or is it greater than 7? And then same with DC, add another DC and another DC, and save that up and format it. So are any of those places off the board? Because if we have to go 2 and it's off the board, then we can't support it, and so we'll return false. Now the last thing that we're going to do is we have to check to see whether after following along this line, we proceed over a group of tokens that are the opposite color and then land on our color. So the last thing that we're going to do is, seeing that we have space and seeing that we're next to an adjacent line, we're going to return whether or not this is a good position now. Just depends on whether or not we have a line match. And we're going to write our third and final helper function that's going to check for a line match of what color, moving in which direction, DR and DC, starting at which position. Well, we're going to start at 2 positions away because that's where we know we have space for support. C plus DC plus DC. Make sure you get these right, because if you get these wrong, the whole thing's going to mess up and it's going to be hard to identify where the problem is. And what board are we looking at? All right, we know next to us is the opposite. All right, so let's just walk through this. We are the who color. We know that immediately next to us is the opposite color. So then what we're going to look for is we're going to say, is 2 away our color in whatever direction we're looking at? And we're going to keep walking until either we end up off the board or we bump into our color. So that's kind of what we're doing here. All right, so for checking our line match, we'll do our third and final function up here at the top above adjacent support. And we'll call function check line match. And we are going to receive the color that we're looking for, the direction that we're going, DRDC, the starting point of our line that we're looking for our color, and the board on which we're looking for it. We will say that if the position that we're currently looking at is triple equals to our color, then there is a line match because we have a partner that will help us flip tokens. And then we'll check to make sure we didn't walk off the board. Well, check to make sure we aren't going to walk off the board. And we're just going to grab this code down here again. If our next step walks off the board, then we don't have an adjacent line match. Let me fix that to semicolon there. If we're about to walk off the edge of the board, then we don't have support. And so lastly, we're just going to do a recursive call, and we're going to say return check line match the next step along the way, R plus DR, comma C plus DC, comma board. All right, so either we will walk off the board and we won't have adjacent support, or we'll encounter a token of our color and we will have support. All right. Let's just look at that real quick and make sure that everything looks okay to me. All right, starting at calculate legal moves for who and a board, we create a temporary data structure where we're going to put our legal moves. We go through each position in our row and each position in our column. We check to make sure it's a place that's open for play. We then look at the northwest position, the north position, the northeast position, and ask if that position provides support. Then we look at west, east, southwest, south, and southeast. And if any of those provide support, then we say that the support, we store that information in our legal moves and then we return it. So when we go to adjacent support, we come up here and we say who, DRDC, RC, and board. We try and figure out who the opposite of us is. So other is white if we're black and black if we're white, and otherwise we have a problem and don't provide adjacent support. If the position that we are looking at and the adjacent support position that we would like support from is off the board according to rows or according to columns, and we can't provide support. If the next position is not the opposite color, then we can't provide support. And if two positions away is off the board, then there's nowhere for us to have a matching token, and we can't provide support either. Then we recursively step to that new position and look to see whether our color is there or not. DRDC, RDR, DRC, DC, DC. We check that position. We say if that is our color, then we can return true. Otherwise, make sure that our next step is not going to walk off the board, and if it is, then false. And then we recursively call RDRCDC. Okay, that looks good to me. All right, and so where are we checking those legal moves? We're checking those legal moves up here when we create our new game. After we set our initial turn to black and create our game board, we calculate our legal moves right after setting our new board. Now, the other place that we have to set our new moves is when we play our token. So let's go to where we play our token. Here's where we receive our message from our client, play token. We come down here. This is where we check to make sure that it's the right player's turn. And then here's where we play our play. We execute our move, and then right after we execute our move, we have to update where the legal positions are. So we'll say game.legalMoves here. It's no longer what it was because we have a new token on the board. And so we'll calculate the legal moves with black because it's black's color, and the current game board because we just added a new token to it. Then we'll do the same thing down here. If black just played, then we will check to see the legal moves for white, and we'll store that before we send it off to the user. All right, So that's enough to calculate the legal moves in our server. Let's run our server and see if we get any errors. And although our client won't be enforcing these legal moves, we'll just go through a sequence and see if we get any errors that we can fix at this point. So what we need to do is we need to run our server. That'll be our first check to see if we have any syntax errors. The server's running. That's great. All right, so now I'm going to come over to two clients here that I have stored for me. And I am going to load them up. And let's see, I have got an inspect browser open. Let's run that. And let's run that. And let me open an inspect browser here. I won't have them on screen. I'll keep them off screen, but where I can see them, just to see if I get any errors from that. And we will just have one player play. And we will have other player play. And we will have them enter the game board and play a game. And I got some kind of error. You can see I didn't get a starting game. So let's see what my error is. Come over here. I see no game exists with this game ID, making a new game. That's okay. But something happened. Can't read property 5 of undefined. So something happened in my create new game. All right, I don't know what it is. So let's take a look. It's probably something simple. So here's create new game. Here's my new game board. Here's where I calculated my legal moves. Let's see. So something happened here. Let's see, I calculated my new moves. I can't read property 5 of undefined. Okay, so let's see, I create, oops, sorry, I went the wrong direction. Create new game, calculate legal moves is down here. Here's legal moves. Here's my board. If my board row or column is space, then I check for adjacent support. Legal moves row, oh, here we go. I misspelled column here. I'm just going to double check to make sure I didn't make that same mistake by looking for the same misspelling somewhere. I don't see that. Okay, good. So let me run that again. Server's running clean. Let me go back to the entry page here. And go back to the entry page here. Have other Don enter the lobby and have Don enter the lobby. Invite the other player, play, start the game. Something else happened. All right, let's see what happened. Now I restarted the server, right? Okay, so that's okay. So something else happened. I found where the bug was. We go to adjacent support. Adjacent support here calls check line match. Check line match is fine. Check line match does a couple checks and then it gets to the bottom here. And when it calls itself, it has to remember to call itself with color at the beginning. And that was the missing part of that function. So if we save that, and now we go back to our client, make sure that's going to run okay. Go back to the beginning. Go back to the beginning. Rerun our server. Everything's clean down in the server output. Come back to our client. We reload it. And this one, I wanted to go back to the beginning. Let's go back to the beginning. Let's walk through the sequence. Invite and play. Everything shows up and we get the initial pieces. It's a little laggy, but it looks okay. I don't see any errors on the inspect tab for the browsers. And if I come to the server, everything is clean too. It's still running. And while it doesn't enforce the legal moves, it does allow just the right color to play, although you can play anywhere, you can see. So the next video, what we're going to do is make sure that you can only play if it's your turn and you're playing on a legal move. All right. So a little debugging there, little errors here and there that you got to get to the bottom of, part of programming. It's a good experience to understand what's behind some of this magic in these web applications. All right. Good luck on implementing it. Thank you for your attention.